Hello everyone. Today we will introduce you to Encin, a runtime library in C programming language for efficient asynchronous I/O and high-performance computation. First of all, let us introduce the team members. Our first team member is Umut Şahin. He is a senior computer engineering student in METÜ. Our second team member is Yağız Şenol. He is also a senior computer engineering student in METÜ. Our supervisor is Murat Mangoğlu, who is a professor at METÜ. He specializes in parallel computing and numerical linear algebra. Now, let us give the outline for the video. Today, we will talk about the problem we are trying to solve, some existing solutions to the problem, how Encin solves this problem, and comparison of Encin with other existing solutions. Now, let's start with the problem definition. The development of modern concurrent systems required in-depth knowledge of many fields, such as multi-threading, asynchronous kernel interfaces, and correct signal handling. When focused individually, these components are relatively easy to use. However, as they are combined, the maintainability and understandability of the code decrease rapidly. This creates the need for tools that simplify concurrent system development. To achieve this problem, several tools have been proposed. One of these tools is Silk. Silk is a C-based runtime system for parallel programming. It is actually an extension of C. That means it has its own compiler and its own environment. It requires the programmer to learn the extended syntax and write parallel code in a non-standard way. While it simplifies the multi-threaded computing, it does not have asynchronous I/O support. As for the I/O-focused tools, one of the proposed solutions is libuv. libuv is built as the event loop of Node.js, which is a very popular and highly used JavaScript runtime. It is an event-based library, focusing especially on asynchronous I/O while providing features for parallel programming. From the functionality perspective, it proposes a similar solution to the problem we defined. As for programming style, libuv is designed with the callback functions. Now let's continue with our proposed solution, Encin. Encin is a runtime library for C on Linux that supports efficient asynchronous I/O and high-performance computation. Our library provides a single interface for both I/O and computation-intensive tasks. It comes with a widely used interface. The interface is specifically designed to bring the very popular async await syntax from many modern languages such as JavaScript, Python, and Rust to the C programming language. The architecture of the Encin can be seen in the figure. In the most basic sense, Encin creates a worker pool where users of the library submit their tasks. These tasks can be user-defined functions or asynchronous I/O tasks. After a task is submitted, available workers pick the task and start working on it. For the asynchronous I/O part, we use a state-of-the-art feature of the Linux kernel called I/O uring. Encin submits asynchronous I/O events to the kernel and returns the result to the user when it's finished. Since this is a library, let us show some code examples that are written with Encin. Conventional thread pool libraries require setup. Encin follows a different design approach to simplify migration of existing applications. A simple Hello World application can be shown in the figure. Note that the only change required is changing the main function to the Encin function. Encin provides different task submission types. For example, users can spawn tasks that can be awaited by another task or spawn a detached task that no other task can await. In this example, we show both normal and detached task spawning. There are a certain number of normal workers of Encin that are set in initialization. If all of these workers are occupied, new tasks cannot be executed despite whether they are simple or not. Therefore, Encin also provides a blocking task type for computation-intensive tasks. This allows high availability for workers in the worker pool. In this example, you can see normal workers delegating computationally expensive tasks to the blocking workers. We noted that Encin also provides an asynchronous I/O interface. In this code, both left and right hand side, we can see an example file read and write operation. The code in the left-hand side is one that is made with regular system calls. The code in the right-hand side is one of that uses Encin. Notice that the code is completely identical, excluding the system calls with Encin calls. Now that we have showed some examples that use Encin, let us continue with the comparison of Encin with other proposed solutions. To test the implementation and compare it with the alternatives, we implemented a simple web server with 4 different approaches. Each implementation is responsible for responding to HTTP requests with SHA-256 hash of 1 megabyte sized file. The hash should be calculated in each request. The benchmark is performed with 16 concurrent connections. As it's shown in the table, Encin outperforms its alternatives in requests per second column and performs similarly to the second best alternative in the lines of code column. This concludes Encin. We hope that our proposed solution helps people in many different contexts. Thank you for listening. You can contact our team members with the given information, and you can reach the source code of the Encin in the given link.